Hello, welcome back to our series, Behind the Scenes of Nautilus. I'm Commander Brad Boyd, Director of Submarine Force Museum, and Officer in Charge of Historic Ship Nautilus. This episode, we're going into tanks. Now, you can kind of hear the noise behind me. That's the ventilation. These tanks are normally closed to the atmosphere, and therefore they can have buildup of gases, either lack of oxygen or buildup of carbon dioxide, carbon monoxide, what have you, because it's not a ventilated space. So we have to ventilate these out, then have gas-free engineering come down, verify the atmospheres are good before we can go in, and I have to have that ventilation running the entire time I'm down there. But with that, we're going to go on into the tanks, and hope you enjoy the tour. Alright, so we're going through. I have Petty Officer Winsel, Machinist Mate Nuclear First Class, is going to be my tank watch for this. So he's going to help pull the ventilation out and let me drop in to one of the storerooms here. Alright, so Professor Winsel here is going to pass the camera down to me. Okay, there you go. You want that other flashlight? Yeah. Okay, here we go. Alright, so it's kind of dark down here. This one, we have some string lights ready to go. So as he's plugged in the string lights now, you can see down here. So all this was a storage area. Alright. So you can kind of see the area of the hull. So this itself is not the hull, it's the metal covering over it so that you can put stuff against it, but that's the curvature of the hull as you see going up over there. Sorry for the light shot there. And we'll come back. This is actually an electronic storage space, so they have extra parts and everything else that would be stored in here in these lockers. So, okay. Now we're going to pause for a second as I climb back out, and we'll go on to the same one in the Chief's quarters area. Hold on. All right, so we finished the first tank. You can see here that I was talking about it's a confined space, so we have to go through all of this to make sure that it's safe for human entry. Going over here, that was the one in crew's mess. Following Petty Officer Winsel here. Going into Chief's quarters. See down in here. So I'll actually get the string light plugged in before we go down now. So he's plugging the string light in. Alright, so plugging in the light, and here we go. This once again is going to hand me down the camera. In, please. Alright, so the string light got caught as we're going through. Plug back in so you can see down here. Duck through the string lights. So, see, more storage down here. Can be used for whatever they need. There's been another spare parts area. Going through. That's actual hull over there, you see? It's curvature. And then, so you can see up there used to be lights down here, but they're no longer, the original ship's electrical system isn't completely intact for distribution. So that's why we have the string lights run down here, so that we can see what's going on. Another spot of hull. One of the things we're doing down here now, the ventilation is solved, we're coming down to do the preservation work. So some of that dirt and stuff that you see is run down the sides and accumulates down here, and we got to get to it. So, all right. With that, we're done here. We'll be going into the battery well, and I'll see you guys in a little bit. Thank you. Come on down. All right, so you see the battery well down here. Now this is actual battery. Fortunately, it's not well lit down here, but the actual battery. Those are desiccant canisters to keep the area dry. That there, and there. We have them again on this side. That's just to keep the moisture that's in the air from deteriorating the space, so we don't go down here nearly as often as you would on an active boat, where you'd be diving the battery well pretty much weekly, so at a minimum. Alright, so here's your batteries. There are 126 cells total. Each one is about 1 foot by 1 foot by 1 foot, well, 1 foot by 1 foot, and it's about 4 feet deep, that's what I meant to say. 126 cells, each one weighs about 1,000 pounds, 126,000 pounds worth of battery in here. You can kind of see, so this is half the battery, goes up to the wall there, and you see the steps. That's because it's following the curvature of the ship, so the hull rounds up there, and then come back behind me. That's how far back it goes. So that's the battery load. The batteries have been drained of their lead acid mixture, so that I don't have that hazard down here anymore. I'm not worried about the batteries leaking acid, which is something you have to replace batteries for. On a boat, you have to replace batteries periodically so that you can maintain good health of them. But the other thing that is down here, well, not down here anymore, but you have air agitation. That's what this piping system is here. So that would actually be routed to the batteries and through them. It's been removed with part of the conversion. But that allows the air to go in the battery, maintain proper mixture, and allows you to agitate the cells, not in a bad way, just to keep the mixture moving, keep things from settling, and battery bus bar, so that's connect power. So, okay, that's the battery well, and we're gonna go back out. Alright, the magic of time warp is in effect. It's been a couple hours, and we've actually pulled all the ventilation out, so now I can have a normal conversation. So I wanted to come back after all that got pulled out. So this is a piece of equipment that supports the battery. This is the Icd panel, so individual cell voltage, and this allows the crew to monitor the health of the battery. And if at any point individual voltage of one of the cells drops to too low, they can actually jumper the cell out so that the battery is no longer charged or discharged through that cell. That way, if any of the cells showing unhealthy characteristics, we can make sure that it doesn't impact the rest of the battery or cause a potential itself, so that we can last longer with that battery before we have to replace all the cells. And we replace all the cells at about every 10 years, plus or minus a few. Well, I'm not sure how frequently I had to do it when Nautilus was there. We've gone through a bunch of battery generations since Nautilus came along, and so we every generation creates basically another step forward in battery technology and how long it'll last. So, but that's what that panel does. Allows us to monitor the battery's performance at an individual cell level. Now, another support system that I talked about down there, but not sure how well you could hear me on the camera, is the air agitation. So air agitation allows us to maintain proper chemical mixture within the battery and not have those chemicals fall out of solution and settle onto a plate. So it just basically keeps everything mixed up and functioning properly. Air agitation does not get rid of hydrogen. Battery ventilation gets rid of hydrogen, and that's what this is. So this is the battery well intake cover, so that way you can pull it off or cover it up depending on what you have going on. But if you have a battery charge going on where you're putting charge back into the battery, one of the byproducts of a battery charge is hydrogen gas. And hydrogen gas is a problem because it's explosive. So you need to get rid of it. So the battery well is ventilated through the ventilation system on board. And that's what gets rid of that hydrogen to keep atmospheres not being explosive. Now over here, we talked about this a little bit last episode. So this is the DC direct current power distribution panels. So the way power is distributed on board the boat. So the primary method of power generation is through the nuclear reactor creating steam, creating hot water. Hot water goes to the steam generator. Steam generator, the water in that gets heated to the point that it becomes steam. It goes down the pipes. do work on either propulsion turbines or electrical turbines. And the electrical turbines, when they spin around, it generates an electric field, generates power, and it generates alternating current, AC, the same type of power you get out of the wall outlet at home, just varying voltage levels that we have throughout the boat. That is distributed around the boat. The battery serves as an immediate backup. And so the battery, and all batteries, generate power in DC, direct current. And so the direct current power has to be able to be transformed into alternating current AC, or from alternating current AC back into direct current DC, and that's done through a motor generator. So you will have motor generators connected to something like this. So it's a 150 kilowatt motor generator. This is the DC side of it. So it'll have either power coming in from the AC side and creating it, transforming it to DC, going to the battery or to the DC buses, or from the battery on the DC side going to AC to then power alternating current loads. And that's how you always have an immediate backup, no matter the second either the reactor has to be shut down or the turbines have to be shut down. If it could just be there's a problem with the steam side of the system. If that ever has to be stopped, then we have battery as immediate backup. The long-term backup to electrical generation on board the Nautilus or any submarine is the diesel engine. So the diesel, if you can't get the electrical turbines running anytime soon, then you have the diesel. You come back at the periscope depth or surface and you run the diesel. So, but that's what these panels are. This is the direct current distribution, so you can just close off to the circuit breakers, and then you also have. Let's see it better over here. This is a propulsion circuit breaker. So, what that does is that allows you to provide power to a electric drive motor that turns the propeller shaft. So if you lose the ability to turn your propeller with steam, then you do have a backup system with an electrical motor to run it, and that's off of a DC motor. So that's how electrical distribution works. Okay, with that, that's the end of this episode's tour. Next episode, we'll actually be going into Chief's quarters and into some berthing, and then following that, we'll go into the galley. And I hope you all enjoyed the tour, and thanks for coming along. Bye.